In this video, we will address song playback.
Okay.
Remember in the last video, we put our new song class into action so that we could store and display notes, but we don't yet have the functionality that will allow us to cause time to progress and cause our notes to move.
All right.
So what we're going to do is we are going to create a more specialized version of our song class.
So a version of the song class whose whole job is to play songs.
Exactly. This song class will be designed to start up with a whole bunch of notes already in place and then progress through those notes tick by tick. So what we can do is up here in the game class, we can add in a new class, and we can call this class SongPlay. So this will be a song specialized for playback purposes. Inside of our new SongPlay class, we'll take out our game sub namespace. Now for the class itself, we do need to make sure that this class extends song.
Makes sense.
Now, inside of the class itself, there is one key area that we need to address. That is the passage of time. Now, as far as the song is concerned, the tick method will be called to indicate that a tick has passed.
And this is a method that we left blank in the base song class, right?
Exactly. Just for reference, we can see over here in the song class, as our first method, we have tick, and we have an empty implementation inside of song.
Now, we actually mentioned the song play class toward the end of the video where we coded the song class. That there were going to be two separate classes that extended the song class, one of which being song play. So this is the one that actually focuses on playing back so you can hear some noise. And then the other class, which we have yet to code, will be for when you're actually, banging out a song in record mode?
Exactly.
Gotcha.
So yeah, that's something good to keep in mind, is that this is the actual song playback class.
Okay.
Now, we're not going to implement it fully in this video. We will add to it piece by piece in order to bring it up to par for all the features of our game. But we are going to continue to build upon this class to use it for the final implementation of the game. So, at this point in time, we're interested in looking at the passage of time. So let's override the tick method. Now we can pull out our call to base.tick because of course we're not doing anything in the base call. And now we need to look at two key areas. There's two events that we want to be able to fire off from inside of tick. We're going to be firing off the beat event as well as the note play event.
So it's kind of like your notes and your metronome.
Exactly. We'll gain both sets of functionality from within the same class.
Okay.
And then we'll do the most important thing, which is make sure that we advance the internal cursor for the song. Again, that would be the cursor field, which indicates our position in the song itself. So we'll actually start with that. We'll say this.cursor, and we will simply increment it by 1. Now we will make sure that that is done last after we do all of our checks.
Right.
We're just dropping in place because this really is the passage of time. Now, as far as the checks, we're interested in looking for two things. One, are we on a current tick that is divisible by the number of ticks in a beat? If so, then that tick is counted as a beat tick. So we can put that check together by looking at our cursor, this.cursor, and seeing if that cursor is divisible by the ticks in a beat. So we'll say if this.cursor modulus this.ticks per beat, if that comes back as 0, then it is indeed evenly divisible, and we can fire off the beat event. Now,
So that would be the trigger beat event.
Exactly. In order to gain access to that event, we'll need to use our trigger method, and we're going to be triggering a beat using that method.
All right, so trigger beat, yeah, I got to keep it straight in my head. Trigger beat's actually a method, and then beat is the event.
Exactly, just to give us enough control with the protected modifier. So that's simple enough, taking care of beat events. Now the next kind of event we need to look at is a note play event. So every time the pattern notices, or excuse me, the song notices that a note correlates with the tick that we're looking at, we need to in turn fire off a play event. Now in order to look at the notes, we'll have to loop through the notes one by one. So we'll put together a for loop. We'll leave the index variable as I, and we'll loop through all of the notes. So that would be this.notes .count. So we'll go through note by note. We'll do the standard practice of giving ourselves a local variable to keep the code concise. So local variable note equals this dot notes sub I. Now we can turn around. Now we've gathered an individual note. We can see if that note is positioned at the current tick of our song. So that would be if note.tick is equal to this dot cursor. That means it's time to play that note. So we'll turn around and we will trigger our note play event. So this dot trigger note play. Now we need to pass in the note that needs to be played, so we'll simply pass the specific note reference along to the trigger method. Now with that actually takes care of the SongPlay class, at least for now. This gets our time passage and 2 of our events in place. And we'll worry about the specifics of other elements in here as they become relevant. For example, handling input from the user or more advanced tracking of time and optimization.
We're building up slowly.
So I will build the project briefly, just to make absolutely sure that we have no syntax errors inside of SongPlay. Now we can turn our attention back to the game class. So looking over here at screen game, we now need to link up this new tick method. If we go down here right below the reset method, of course being a screen means we have access to an update method, which we can override. And we'll pull out our call to base.update. Now inside of update, naturally this gets called by the game itself. Inside of here we need to pass this update occurrence onto the song. So that means we'll call song.tick.
And with that, we should now have time driving forward in our song.
Exactly. At this point, as update is called, time will progress inside of our song.
Gotcha.
Now we need to make sure that we start using a SongPlay class instead of a standard base song. So up here inside of the reset method, we'll change the song instance to be a new song play. You will note that we are still storing the song field as type song because all of the methods that we'll use are already defined in the base class.
Sure.
We just need to gain access to the functionality in the SongPlay class. Now, once we get this song defined, we can turn around and add a handler for the note play event. So we can jump down and we can say that song.notePlay. We'll grab the note play event and subscribe a new listener. So I'll tab out twice, once to get the new note handler put in place, and again to generate the method that should handle this event. So this results in the method called song_notePlay. And now inside of this notePlay method, all we're going to do is make a call to our sound engine and tell it to play a note on a specific track. We can gain access to our sound engine by looking into global state. And there we have the sound engine field. And sound engine is going to take in a call to the play method. Play needs to know what track by index we're looking at. So we can take our note and pass in the track value. So that's really where the index-based playback of our sound engine really comes into play. The fact that we don't have to do any type of additional lookup or index resolution. We have an index stored directly in each individual note because it has an index-based track.
Gotcha.
That gets passed directly to play, and then we have very concise and simplistic code. Now that we have our notes set up to play, let's jump down to the draw method and make sure that they visually move across the screen as time is progressing. So down here inside of draw, we want to jump into our position value where we're setting up our offset with our center, looking at our note tick. What we'll do is we'll take that tick and we'll subtract the current cursor position. So we'll look into song, we'll grab cursor. So the reason we're subtracting is so that the notes move to the left of the screen or decrease in an X value.
So the cursor is going to constantly tick up, which will constantly push our song off to the left.
Exactly. So if we've progressed 10 ticks into the song, then we'll subtract 10 pixels in X and thereby move left across the screen. Now, while we're in the draw method, let's put another piece of code into place. let's actually draw the current tempo out to the screen as well.
Okay.
So we'll jump in here right after we've drawn all of our notes, and we'll drop in a few lines for the tempo. We'll begin with a local variable, and this will be a string that we will call BPM text. And we'll set that by doing some string formatting. String.format, and the string we want to assemble is simply a readout for our BPM. So we can see BPM is currently argument 0. And
which will correspond to song.bpm.
Exactly. So that means for the value we just drop in song.bpm, and that takes care of our string. Now we can turn around and draw that to the screen. So we'll grab sprite batch.draw, where we will take in, actually let me back up. Rather than drawing a texture, we're actually drawing text, so that would be drawstring. We need to pass it a font, so we'll grab style.font small. The text is simply BPM text. The position will be gathered from style positions.bpm. And finally we need a color, so we'll look into style colors and grab text BPM. So we can finish off our call to drawstring. Now we have not yet set up these values inside of our style configuration file. So at this point we'll jump into style.xml, which we had open earlier and has probably fallen off the screen. We could drop down in here and find style, or we could navigate to content in the Solution Explorer. I'll just bring it up inside of the editor. Then two places we need to look at: style positions. We need to place BPM at a value of 10 and 10. So we'll still place the BPM readout at the top left corner of the screen. We'll just give ourselves a little bit of padding.
Sure.
Then we need to set the BPM text color. So up here in colors, we'll grab text BPM and set this to a value of 169 as gray. So 169 for the red, green, and blue components. So with that, we'll make sure that we save out our style XML file, and then we can jump over here back to our game. There's one last thing we need to address inside of game, and that is in the input section. Since we're now putting together an actual playback scenario, we will take out the manual input that gets us over to the score screen, because in actuality we don't advance the score by pressing select, we advance the score by the song ending.
Right.
So we'll go ahead and pull that out entirely. Now, before we can jump in and see this working, let's see. We do not yet have the correct tempo set because we don't have our tempo calculation. But just to be adventurous, let's see what we get if we jump in and play the game.
Sure.
So if we build and run, we get our menu options. So at this point, if all works well, we're looking for notes that move as well as sounds as our notes cross the hit line. So we'll jump into single player and then enter again. So we do get playback. It is rather slow, though.
It's the is that the default BPM coming through?
Actually, it's not. If we look at our default BPM, that is set to 120,
which should be a lot faster than
which
that.
Eighth notes at 120 should be a lot faster than that. What's happening is we have not yet set our game's update interval. So we're still running at the standard 60 frames a second, which is somewhat below the actual tick rate if we were to use our ticks per beat here inside of song of 96 and then run the game at 120 beats per minute.
Ah, gotcha.
And that means we need to go all the way back to our music demo, if you remember, where we made the tempo calculation. So we took into account BPM and we kicked out an interval in terms of a time span. We need to do the exact same thing here, except we need a good place to put the actual conversion method. We don't want to drop it directly into the game class. So if we bring up our game's code here, since we can't address the game directly, and we don't want to begin cluttering the game with music specifics. So what we'll do is we'll actually jump to global state, and even better, global state has the current game instance inside of it. So we'll actually drop a method here inside of global state that will allow us to set the tempo. So this gives us a very good high visibility place to grab tempo. Since tempo is dependent on the very core of our game class, we're actually using XNA's update code to give us the desired interval. So here at the end of global state, we'll put together a new static method. We'll make it a public method. We'll have no return, so we'll have a void return type, and the method name will be set tempo. And just like we did before, we're going to be taking in a tempo in terms of beats per minute, so we'll give ourselves an integer called BPM, and we'll also take in the number of ticks in a beat, so that we can subdivide the update calls per per beat. So we'll give ourselves a second integer called ticks per beat. Now, inside of this method, we need to convert our BPM value, taking into account our ticks per beat, and kick out an interval in terms of 100 nanosecond ticks. And the reason for these 100 nanosecond intervals is that feeds nicely into a time span. So we'll drop down a local variable of type long. We'll call this variable interval. And just as a note, this is exactly what we did inside of the music demo. I just decided to retype it here to make it clear exactly what's going on. But this should be very familiar if you've gone through the music demo itself. So our interval, that needs to be based on a set number of ticks. So to begin with, we'll get a number of ticks in terms of minutes, since we're dealing with beats per minute. So I'll grab timespan dot ticks per minute to give us 1 minute's worth of time, and we'll divide that span of time by the individual slices of time per update. And we get that by taking our beats per minute and multiplying that by the number of ticks in a beat. And that gives us our tick-based subdivision. Then we can turn around and use that interval to make a new timestamp. And where that timestamp is useful is, of course, the target elapsed time of a game. So we need to look at the current game instance, which we have here as the field inside of global state. So we'll grab game instance dot target elapsed time, and we'll set that to be equal to a new time span, and we'll give our time span in the form of 100 nanosecond ticks, which means we'll plug in interval. So that should finish up our call to our new time span, and at this point we should have the ability to set the tempo of our song. Now, in order to set up the tempo, what we'll do is we'll jump back into our game, screen game. Then once we get the song set up, before we add the handler, we'll make a call to global state.setTempo. So setTempo is going to need to take in a tempo in beats per minute.
And then a ticks per beat.
Exactly. And both of these are stored in the song itself. So we're just going to be passing some values along, song.bpm and song.ticks per beat. So really it's just providing a connection between our song and the game's overall tempo. Just to clean things up a little bit, let me actually pull this line out. I'll put it in right after our call to note play.
Okay.
So at this point, we should be able to run the game and get the correct tempo for 120 beats per minute. So we'll jump in single player, select again, and our two measures of song play out just fine. And you'll notice that we don't have the end event put in place yet. So our song scrolls off the screen and we stay at game forever, unless we hit the back button. But again, we don't have to worry about hitting select and going past to the score screen.
Right.
We'll make sure we wait for the appropriate time when we get the events linked up to get us over to the score screen. Now, one last thing I would like to do is to put the lead-in beats calculation into play.
Because right now we have no lead-in at all.
Exactly. The moment you hit the game screen, you hear your first notes being played, and you start at tick 0, and everything begins progressing. Would be very startling to a player if they jumped in when what would feel like the middle of a song. So what we'll do is we'll jump into our song right after we create it, let's set the lead-in beats, because if you remember, lead-in beats will default to a value of 0.
Right.
So we need to specify that from somewhere. And what we're going to do is make an entire measure of time go past before the song starts. So we'll take our song and set our lead-in beats to be equal to the number of beats in a measure. And we can gather that by looking at song and taking beats per measure. Then once we get this value plugged in, we need to make sure that we turn around and call reset, because it's actually the reset method of song. If we scroll down in our song class, reset is what takes lead-in beats into account and applies that to the cursor. So we need to call song.reset. And I'm actually going to place this called song.reset last, right before the tempo, since we want to make sure that everything field-wise, everything property-wise is set up on the song before we call reset.
Sure.
Just to make sure that the reset function is working on the most up-to-date state of the data
that
as
makes
it can.
sense.
So now let's jump into play, and we should see a measure's worth of time go by before the song starts. So there we go.
Nice.
And we have playback, both visually and audibly. So that brings us to the end of the music playback lesson. Again, the idea was to advance from our initial song usage, where we could store notes, and apply the concept of time passing, which is what we did inside of SongPlay.
Mm-hmm.
We addressed that inside of Tick. We caused time to pass by updating the cursor, and then fired off specific events if we landed on interesting ticks that landed on a beat or landed on a note. And then once we had the SongPlay set up, we went back to game and wired everything together by putting in calls to update, listening for events, and so forth.
Very cool.
So with that, I will wrap up this video.